Today we're going to be looking at the Fluke 87.4 True RMS multimeter. We'll be looking at ways to take a few basic measurements and going over some of the features of it. So with that, let's start looking at some of our options for measuring voltage. First, we have this position. In this position, it can be used for measuring AC voltages. The same applies for this position, albeit this position is only good for smaller voltages that are smaller than a volt. Now let's look at the DC. This is what we'll be using in the labs that will be coming next. What would be a better way to say that?
First of your labs.
The first several labs.
Yes.
Now, when you're sure that you'll be measuring a small value, you can use this millivolt setting. This will be able to measure much smaller voltages and get higher accuracy than the setting with just V, but at the same time has a much smaller range. Now, let's look at some of the ways we can measure, or I guess the only way we can measure resistance. Using this setting, we are able to look at the resistance of a component and determine some of its properties. If we want to look at the current in a circuit, we can go to either this setting, which is milliamps, or this setting, which is microamps. Now, we want to be sure that we have the right range before we select milliamps. Additionally, you'll notice that the screen right now displays leads or fuse. This means that I don't have the leads connected properly for this configuration. We'll go over this later in the video. So, with that said, let's start off by measuring the value of a resistor that we have. Okay. So, we have a resistor. We have no idea what its value is. How can we determine that? Well, first, we want to make sure that our leads are set up correctly. As you can see, I have the black set to common. For any measurement, this will be the case. I would also have this set to the rightmost input. Now, all we have to do is connect each lead to the resistor. It doesn't matter which side that we use for the purposes of this. As you can see, we're getting 9.946 thousand ohms. So about 10K. Now that we've done that, let's look at how we can use the multimeter to measure the current through a circuit. We'll set up the Heath 2718 power supply in a simple circuit. Notice that the power supply is off while I'm changing connections around. Now, this is what the circuit alone would look like. Simply the two leads connected to the resistor. However, if we wanted to measure the current through the resistor, we have to make a break in the circuit. We want to make sure that all the current that is flowing through this resistor also flows through our multimeter so that we can measure it. So to do that, first off, we want to set up our leads. For the purposes of this, for now, we'll be using this 10 amp max fused setting so that we can be sure that we aren't going to use too much current. So, with that, all we have to do is connect one part of the probe to the one end of the thing we want to measure current through, and then continue the circuit by connecting this other probe back to where the current flows through. So as you may be able to see, the current will flow from the power supply through the resistor, through the multimeter, then it'll come out this black lead again and go back into the power supply. That means when we turn on the power supply, we should be able to get a current reading as long as we have our multimeter set to measure current. So with that, let's turn on our power supply. Now, as you can see, we aren't actually getting very large measurements. Now this could be because our power supply either isn't outputting anything or the circuit isn't hooked up correctly. However, in this case, it's because the current that we are measuring is so small that we won't actually be able to see it in this view. So to fix that, what we can do is first power off our power supply. Then we can go from the 10 amp max fuse to the 400 milliamp fuse and change to the microamp setting. This will allow us to get a much higher degree of accuracy. So when we power on our supply once again, we will see that we will get about 500 microamps. So now that we've done that, what other measurements can we make with this multimeter? Well, let's take a look at the voltage across this resistor when we have it hooked up to the power supply. First, let's go ahead and disconnect our circuit. And then we can reconnect it. This time, because we aren't measuring current, we're actually going to want to leave the circuit as it is and have no breaks in it, so that all the current goes through the resistor and back into the power supply without going into the multimeter at all. So, to measure voltage, we're going to want to set, first, we want to set it to the voltage setting. However, that's not going to be it. We need to make sure that we have our red lead connected back over on this rightmost input. This is because the way the multimeter works while measuring current and voltage is significantly different. So with that, we can then power on, we can then make our connections. Across, this time we want to connect our multimeter across the circuit. So none of the current will actually flow into the multimeter. Instead, it will choose the path of lesser resistance and go back into the power supply without going through the multimeter at all. So when we turn on our power supply, we can see we get 4.98 volts, which is the 5 volts that we expected.